BMS demanded that the system be configured for optimal efficiency. This is an example of one 11 kilowatt fan application running at 25 Hz while absorbing 56% current at the motor shaft. By entering the energy optimization group and triggering the flux optimization parameter, we see that when we return to the main screen, a fall in motor current without affecting the process speed or fan performance has been achieved. In fact, the motor shaft power has reduced by 27% in this application. When replicated across the site, this simple parameter change has the potential to make a significant input to the site objectives and a contribution to BMS Sustainability 2020 program. At BMS, the dual fan AHU control method ensures that both supply and return fans operate at reduced speed. This is typically 50% of motor nominal speed. For a centrifugal fan application, this takes full advantage of the Affinity Law of physics. The power absorbed by the load is proportional to speed to the power of 3. This represents a power saving of up to 80% in many applications. This relationship between power and speed can be applied to centrifugal fans or pumps. The combined effect of this reduced speed control and VSD program optimization will have a dramatic effect on site power consumption.
These units, based on their design, they're running 24/7. So the utilities technicians or maintenance technicians or engineers working on the facility will never have an opportunity to actually work on the unit and to see the design as in its full or how it works. So we developed the training rig so the technicians can get hands-on experience how the unit works.
So behind me here, we decided to mount all of the essential components on one single unit. And not alone that, but to make them work in both hand and auto modes. When we were asked originally, we thought it was a wonderful idea, because quite often we are asked back to site 3, 6, 9 months down the road to try and retrain. What we have here is a permanent fixture that allows continuous ongoing training and development.
But another very important thing is we can use it to reinitiate faults. So typically a fault might happen on a shift over night time or a weekend, and the day support team may not see the fault until the following Monday or Tuesday. And then they're trying to find out what happened and recreate the fault and make sure it won't happen again. By having this training and development rig, we can recreate the fault, see what caused it, and by having all the different systems, the building automation, the field controls and the fire detection system integrated, we can see which system caused the fault and what needs to be done to overcome it if it happens in the future.
The dual fan AHU simulator contains all the control elements that are directly connected to the VSD system arranged on a display platform. This electrically functional system is designed to replicate all AHU key control elements and is interfaced with the main building automation system via a local DPU cabinet. The adjacent fire alarm demonstration unit is also connected to this fan control simulation rig. The outside air inlet damper supplies fresh air to 2 active parallel systems, creating a fully redundant solution. Either parallel section can be isolated individually from the main common supply by means of 2 associated isolation dampers on the inlet and outlet side of each fan unit. Should one unit fail, the running standby increases speed to meet process demand. The large outlet air main damper is controlled by 3 actuator units. The supply air section has frost thermostat and overpressure switch protection. The system is interfaced with the fire alarm IO unit. This supply section control philosophy is replicated on the return side with an additional BAS-controlled mixing damper permitting recirculation of a controlled amount of air. All AHU control devices are interfaced with the ACS 880 drive units via an interface cabinet. In conjunction with this interface cabinet, the ACS 880 embedded adaptive programming software is used to eliminate the requirement for expensive relay logic control of damper actuators and damper status feedback. Expensive PLC idle points are minimized. In this way, PLC hardware costs were dramatically reduced. IDO point cabling is eliminated, PLC programming time is reduced, and the DPU footprint is smaller by up to 50% in some cases. In the event of the AHU unit losing communications over the embedded Modbus, manual controls is available at the VSD units. A further enhancement was the installation of a jog button at the slim box. The jog functionality is limited in VSD software to low-speed operation at 5 Hz for a short duration of 5 seconds and is only available in hand control mode. It is designed to permit bump testing for function and direction following maintenance only. SIL-rated emergency stop functionality is available to test for each VSD motor unit. A motor brake function has been installed to simulate a motor load and stall condition. This unique training and development AHU simulation unit can now be used to test process enhancements and verify integrity of new control methodology into the future.